An arc fault circuit interrupter, or AFCI breaker, is designed to protect against electrical fires caused by arc faults. If an AFCI breaker won't reset, there are several possible reasons to investigate. Firstly, loose or corroded connections can prevent the breaker from resetting. Thoroughly check all connections at the panel, receptacles, and switches, making sure they are tight and free of any corrosion. Secondly, faulty wiring can cause AFCI breakers to trip. Inspect the wiring for any damage, splices, or loose connections. AFCI breakers are highly sensitive to changes in current flow, and poor wiring can easily trigger a fault. Thirdly, an overload on the circuit might be the problem. Verify that the circuit is not overloaded by disconnecting some devices. AFCI breakers can trip if the total load exceeds their rated capacity. Fourthly, make sure the correct breaker type is installed. Ensure that the AFCI breaker installed is the correct type and amperage for the circuit. Using the wrong breaker can cause nuisance tripping or, worse, fail to protect the circuit properly. Fifthly, consider a ground fault. Even with a high resistance reading of 1.5 megohms between neutral and ground, there could still be a high resistance ground fault that prevents the AFCI from resetting. A small current leakage to ground can be enough to trip the breaker. Sixthly, look for signs of an arc fault. AFCI breakers are specifically designed to detect and interrupt arc faults. Carefully check for any signs of arcing, such as charred wires or discolored terminals. Arcing can occur due to damaged insulation or loose connections. Seventhly, the AFCI breaker itself could be faulty. Even if new, the breaker might be defective. Try replacing it with another new one of the same type and amperage to rule out a malfunctioning breaker. Eighthly, interference from other devices can affect AFCI breakers. Certain electronic devices, such as dimmers or television sets, can sometimes interfere with the operation of AFCI breakers. Disconnect these devices temporarily to see if the breaker then resets. Ninthly, examine the neutral-ground bond. Verify that the neutral and ground conductors are properly bonded at the main panel. A poor or missing bond can prevent the AFCI from resetting correctly. The neutral and ground should only be bonded at the service entrance. Tenthly, reverse polarity can cause issues. Ensure that the incoming power is connected with the correct polarity. Reverse polarity can prevent the AFCI from functioning properly. To further diagnose the problem, use a systematic approach. Begin by turning off all loads on the affected circuit. Then try resetting the AFCI breaker. If it resets, turn on each load one at a time to identify any device causing the trip. If the breaker still doesn't reset with all loads off, disconnect the neutral conductor of the circuit at the breaker. Measure the resistance between the neutral conductor and ground. A high resistance reading, such as 1.5 megohms, indicates that there isn't a direct short circuit. However, a lower resistance reading could indicate a ground fault. Next, inspect the wiring along the entire circuit. Look for any signs of damage, such as frayed insulation, pinched wires, or loose connections. Pay particular attention to areas where the wiring might be exposed to moisture or physical stress. Check all the receptacles and switches on the circuit. Make sure they are properly wired and in good condition. Loose connections or damaged devices can cause arc faults or ground faults. If you find any damaged wiring or devices, replace them immediately. Use appropriate wiring techniques and materials when making repairs. Ensure that all connections are tight and properly insulated. If the AFCI breaker continues to trip after checking the wiring and devices, consider the possibility of a hidden ground fault. This can occur if a wire is touching a grounded metal object inside a wall or junction box. Use a megometer to test the insulation resistance of the wiring. Disconnect the wiring from the breaker and any loads. Then measure the resistance between each conductor and ground. A low resistance reading indicates a ground fault. If you suspect a hidden ground fault, carefully inspect the wiring in the walls and junction boxes. Look for any signs of damage or contact with grounded objects. If you can't find the source of the ground fault, you may need to call a qualified electrician to help. Another potential cause of AFCI breaker tripping is electromagnetic interference, also known as EMI. EMI can be generated by electronic devices such as computers, televisions, and fluorescent lights. This interference can disrupt the operation of the AFCI breaker and cause it to trip. To mitigate EMI, try moving the affected circuit away from electronic devices. You can also use shielded wiring or install a line filter to reduce the amount of EMI on the circuit. AFCI breakers are designed to protect against both arc faults and ground faults. An arc fault is an unintentional electrical discharge between two or more conductors. A ground fault is an unintentional electrical discharge from a conductor to ground. AFCI breakers use sophisticated electronics to detect these types of faults and trip the breaker before a fire can start. There are two types of AFCI breakers: branch feeder AFCI breakers and combination AFCI breakers. Branch feeder AFCI breakers protect against arc faults in branch circuits and feeders. Combination AFCI breakers protect against both arc faults and ground faults in branch circuits. Combination AFCI breakers are more sensitive than branch feeder AFCI breakers and are required by the National Electrical Code (NEC) in many locations. When replacing an AFCI breaker, it's important to use the correct type of breaker. Using the wrong type of breaker can reduce the level of protection provided by the circuit. If you're not sure which type of AFCI breaker to use, consult a qualified electrician. AFCI breakers are an important safety device that can help prevent electrical fires. By understanding how they work and troubleshooting common problems, you can help ensure that your home is protected from electrical hazards. Remember to always turn off the power to the circuit before working on any electrical components. If you're not comfortable working with electricity, call a qualified electrician. To summarize, when an AFCI breaker won't reset, firstly, check for loose or corroded connections. Secondly, inspect for faulty wiring. Thirdly, verify that the circuit is not overloaded. Fourthly, ensure the correct breaker type is installed. Fifthly, investigate potential ground faults. Sixthly, look for signs of arc faults. Seventhly, test the breaker itself. Eighthly, consider interference from other devices. Ninthly, examine the neutral ground bond. And tenthly, check for reverse polarity. By systematically checking these potential issues, you can effectively troubleshoot and resolve AFCI breaker reset problems. Always prioritize safety and consult a qualified electrician when needed.